All right, so we are getting now into trig functions. So the fancy word is trigonometric. We just call it trig usually. This is really exciting. This is like probably my favorite thing that we learn all year. So I'm really excited about this. If you liked geometry stuff, this is probably right up your alley. I think it's really cool. I think you'll like it too. Usually people really like this stuff. Okay, so what trigonometric ratios are? These functions are just ratios of lengths of your sides of your right triangle. So think of trig as just meaning math that deals with right triangles. So when we talk about trig functions, we're talking about ratios of the lengths of the sides of the triangle. Right triangles, if we're being more specific. So when you look over here at this triangle to the right, you see this little symbol in the angle called theta. So this is a right triangle. You have your right angle here. Then you have two acute angles. That theta, so draw it kind of like a zero with a little loop through it. That is called theta. It's a Greek letter. And basically it's just used to represent an angle. You'll see it a lot. So when you're actually looking at this triangle over here, then there's three sides and they're all kind of referred to as different things. The one that never changes is the hypotenuse. So you learned this back when you learned about right triangles. The side that's across from the right angle, okay, the longest side of your right triangle is called the hypotenuse. To think about how I spelled that. Hypotenuse. Okay? I'll erase this arrow. Then, the other two sides are kind of interchangeable. They depend on what angle you're talking about. The angle that's across from theta is the opposite side. Opposite because it's on the opposite side of the triangle. That's pretty straightforward. And then the side that, or the leg, you'll also hear it referred to, the side that's right next to the theta, we call that adjacent. Adjacent means next to. So you have your opposite side across the triangle, adjacent is next to. And then your hypotenuse is always across from the right angle. So you have six functions here that you can see right below this, where you have sine, cosine, tangent, cosecant, secant, cotangent. So these are the six things that you're going to learn today, and we're going to talk about how to use them. The first three are on the left side of this little organized chart here, and these are the main ones, sine, cosine, and tangent. So first of all, sine, you'll see it written as sine, S-I-N, theta. And yes, you do have a button on your calculator that says sine. So this means sine of an angle. And sine is the opposite over the hypotenuse. Then you have cosine. You see this written as C-O-S, theta. That is equal to the adjacent side over the hypotenuse. And I think when we do an example, this will make more sense, just FYI. Tangent, you'll see written as T-A-N of theta. That's equal to the opposite side over the adjacent side. A way that you'll often see sine, cosine, and tangent remembered is using an, what is that word? Acronym. An acronym that helps you remember sine, cosine, and tangent. The acronym is SOHCAHTOA. You've probably heard this before. People love talking about SOHCAHTOA. So what this means, what this helps you realize, is you have your sine, which is your opposite over your hypotenuse. Okay? Then you have your cosine, which is your adjacent over your hypotenuse. I'm abbreviating just so you can see what this means. Then you have your tangent, which is your opposite over your adjacent. Okay, so whenever you need to remember which one's which, you can use SOHCAHTOA to remember it. It's just the sine is the first three letters, cosine is the next set of three letters, and tangent is the last three. Then you have something called reciprocal trig functions, okay? So these are formed by exchanging the terms in each ratio. So by exchanging the terms, all I mean is you flip the fraction upside down. So sine and cosecant go together. This is something that's sometimes hard for people. Cosecant and cosine do not go together. So get that out of your head. Cosecant is written as CSC theta. Okay? Cosecant of theta is just the opposite of sine. Sine was opposite over hypotenuse. Now we have hypotenuse over opposite. Same thing with secant. Secant is SEC theta. Instead of being adjacent over hypotenuse like cosine is, now it's hypotenuse over adjacent. And then cotangent is COT, and again, it's just tangent flipped upside down. So adjacent over opposite. Okay, that's the basics. Now we're going to actually use them. So on example 1, refer back to this section here whenever you're doing the assignment today, because you'll need it before you have all these memorized. So in example 1, it says, given the right triangle, write the 6 trig ratios for the given angle with measure theta. So you have theta right here. So we're going to list out all 6 trig ratios. I would set it up, like when you're doing it on your piece of paper, exactly like we just wrote it down. It helps you keep it organized and remember what goes with what. So in the first column, I'm going to write sine theta equals, cosine theta equals, tangent theta equals, and then I have my reciprocal functions. So cosecant theta equals, secant theta equals, and cotangent theta equals. So, starting with my sine is the opposite over the hypotenuse. So locate your right angle. Here's your right angle. So you have your hypotenuse is here. Opposite would be across the triangle from theta, so that would be 12. So my opposite is 12 over my hypotenuse, which is 37. Then, let me erase these. Then your cosine is your adjacent over your hypotenuse. Okay, adjacent is right next to theta. Hypotenuse is the long side. So I have 35 over 37. Then, with tangent, those are the 2 legs. So opposite over adjacent. Opposite, again, would be 12. 35 would be adjacent. Okay, 12 is across the triangle. 35 is right next to theta. Once you have sine, cosine, and tangent, all you got to do is flip them upside down to do cosecant, secant, and cotangent. So for cosecant, I have 37 over 12. I just flipped that over. For secant, I have 37 over 35. And for cotangent, I have 35 over 12. You don't even have to really think about those. All you gotta do is flip the fraction over. So sometimes not all 3 sides will be given to you. So if you look at example 2, it says, knowing that tangent, this is a typo, cross that out. It says, knowing that tangent of theta is 15 over 8, what are the other trig ratios for theta? Whenever you're given a problem like this, always, always, always start by drawing a right triangle. That will be very important. So, and it does not matter what your right triangle looks like. It could look like any old right triangle. So I have a right angle, and I'm going to pick one of the other angles to be theta. It does not matter which one. Then, tangent of theta, I think, okay, what is tangent? Tangent in SOHCAHTOA would be opposite over adjacent. So that means my opposite side is 15, my adjacent side is 8. So then we figure out, okay, how can we find this missing side, the hypotenuse? Think back to something called Pythagorean theorem. A squared plus b squared equals c squared. It helps you find missing sides of right triangles. So use this to find missing side. So I'm going to plug in the 2 legs for a squared and b squared. Remember, your 2 legs are a and b, and then your hypotenuse is c. So I have 8 squared plus 15 squared equals c squared. 8 times 8 is 64. 15 times 15 is 225. Then if I add those together, you should get 289 equals c squared. And then I would take the square root of both sides. So you end up with c equaling 17. So I know that this side of my triangle is 17, my hypotenuse. Another way to check to make sure your math is right, your hypotenuse is always the longest side. 17 is bigger than both 15 and 8, so chances are I probably did my math right. If I had 15 and 8 as my legs and then I solved that and I got 11 as my hypotenuse, you know you did something wrong because your hypotenuse is always the longest side by definition. Now I'm going to fill out all of the trig ratios. So once again, I set them up: sine, cosine, tangent. Then you have, I'm going to put equal signs there. Then you have cosecant, secant, and cotangent. All right, so starting off with sine, SOHCAHTOA. So is opposite over hypotenuse. So my opposite side would be 15. My hypotenuse is 17. So I have 15 over 17. Cosine would be my adjacent over my hypotenuse. So 8 over 17. My tangent would be opposite over adjacent. So that's actually what was given here, but you can always double check to make sure you did it right. Opposite side would be 15, adjacent side would be 8. So yes, we did that right. Then for your reciprocal trig functions, just flip them all over. So 15 over 17 for my sine becomes 17 over 15 for my cosecant. My secant then would be 17 over 8, and my cotangent would be 8 over 15. All right, that's the basics. On the back side, we're going to solve some equations.